We are presenting the Madrid Green Data Space, a project that has been funded by EIT Digital and EIT Climate Kick under Cross-Kick activity. In this project, we focus on two different perspectives. On the one hand, we try to provide horizontal support, not only for our project, but also for other sister projects that were run at the same time, for the design of the digital layer of the deep demonstrator, in the case of Madrid. In this horizontal support, we have been working on different levels, on technology, on the data governance, and finally on the data asset cataloging. So basically, we have provided an initial prototype of a digital layer which could be used for all the experiments that are currently in the experiment portfolio of the Madrid Deep Demonstrator. On the second part, we have worked on a very specific vertical domain related to green data. What we have done is that we have developed several data processing tools and dashboards with several indicators that are related to green spaces in Madrid. These indicators are generated from raw data available as satellite data, LiDAR, open data, and other data sources that we have had access to. If we start with the horizontal support, the Madrid Green Data Space architecture is based on the IDSA, Industrial Data Space Association Reference Implementation, and it is also aligned with GAIAX, which is the current initiative for providing data space technological support for data spaces, for the European data spaces. In this context, we have been working on connectors, so as to access different types of data sources, mostly geographical data and also CSVs, spreadsheets, and so on. We have also been working on connectors that have allowed us to process data that was available as raw data in order to generate the indicators. And finally, we have been also working on connectors that could be used by data consumers, more specifically by web applications, the dashboards that we have been generating that are accessing the data that is available in the data space. We have also worked on a web data portal, taking into account that we needed to present the data in a somewhat different form to the one that was being used in the IDSA reference implementation. And finally, we have been also working on simple authorization services that show the strength of having open data and private data in the context of a data space. This is related to the architecture. In the context of this project, we have been also working on a data governance model that can be used by any city, like Madrid, in order to understand how to construct, how to build data spaces for very specific purposes. In this case, we have focused from a general point of view on providing data governance definitions, describing the types of data, their life cycle, considering all types of data that can be handled in the data space, as well as identifying stakeholders, main responsibilities, and functions. In this context, we have provided an overview of what it could be an organizational structure for the management of a city-related data space, like the one that we have built for Madrid. And finally, we have provided more details on processes and protocols that can be used for the management of city data spaces, especially focusing on how to identify and catalog data sets, how to extract and update them, how to perform data integration and cleaning operations, and finally, how to generate metadata and how to publish it. This document is available in Spanish for city officials to understand how they could enable or promote city data spaces in their cities. We have been also working on a data catalog. This data catalog currently contains 40 data sets coming from different providers, mostly by the Open Data Portal in Madrid, but also private providers. All the descriptions are based on the DCAT data model, which is being used across open data portals in Europe, and it is queryable via a Sparkle endpoint. When we move into the vertical layer, we have been working with data sources coming from different providers, which have been made available using the IDS architecture, the previously presented architecture. And we have derived 5 indicators, some of them already well known and others that we have created that are related to understanding better the green spaces in the city. So these indicators are NDVI, Green Space Index, Green Space Proximity Index, a green space density, and a green space built space ratio. All these indicators have been generated and calculated across neighborhoods and census tracts, and they are visualized on a layer on a map with some interactive visualizations that can be used not only to diagnose, assess the green infrastructure in the city of Madrid, in this case, but also to design, implement, and monitor policies and their application in the context of a city. We will now move into a brief demo of this interactive visualization. So if we move into the dashboard, the rest of components are available over here in the corresponding website. We can see that we have different layers that we can use based on neighborhoods, districts, census tracts, and also, I mean, we may remove those layers. And we have the 5 different indicators that have been generated. Yeah? For instance, NDVI with the different values that they have in each of the census tracts, and coming together with some histograms that can be used in order to provide policies or discuss on policies that may be used whenever we want to understand the evolution of these indexes according to some of the policies that we are generating. So this is the case for NDVI. We have also the GS index, as we can see over here, the one related to density, built space ratio, or proximity indexes. This is the work that we have tried to do in this context in order to allow city officials or any other interested parties understand the data that they have at hand. It is very narrowly focused, very specific on the green infrastructure, but this architecture may be available, may be relevant for many other types of data spaces, of data sets and problems that may be relevant for the city.